All right, we're going to graph some motion here. And so we're going to use a simple example for our motion graph, and we're going to use the scenario of you walking to school. And so you're going to start at point A, which is your house, and the first thing you're going to do is walk to your friend's house. So I'm going to draw a line from your house to your friend's house. Now, the time it takes you to walk from your house to your friend's house is going to be 30 minutes. And we're going to say that your friend's house is located 2 miles from your house. All right. After you get to your friend's house, you are going to walk with your friend on to school. And so I'll draw a line from your friend's house to school. It's going to take you 40 minutes to walk from your friend's house to school, and you're going to do that a distance of 4 miles. So your friend's house is located 4 miles away from the school. All right, and so the next thing that we can do is we can go ahead and take our information and we can plot it onto our graph. And so I'm going to label point A on our graph, and we can look at our graph. The vertical axis in the y direction is displacement in miles, so that's how far we're traveling, and the horizontal or x-axis on our graph is time, and that time is displayed in minutes. And so if we're at our house, the starting point, it's going to be 0 miles we've traveled and 0 minutes of time. And so I'm going to put a point at that spot, and I'm going to label it point A as your house. Now, 30 minutes later and over 2 miles, so I find 30 minutes and 2 miles, and where those lines intersect on my graph, I'm going to put a point, and that's going to be point B, our friend's house. And so I'll label that point B. Now let's say when we get to our friend's house, we don't immediately leave for school. So I'm going to plot another point right here on our graph, and I'm going to label that point D. And so point D is going to be the place where we are just waiting for our friend about 10 minutes before we go on and walk to school. Now, when we continue to walk on to school, we're going to walk 4 more miles. And so I'm going to go up from this new point right here. We're at our friend's house. So I'm going to go 1, 2, 3, 4. So we're going to be on the top here. And it's going to take us 40 minutes to do that. And so if I go over 10, 20, 30, 40, the plot we're going to be at is right there, the point. And that point represents the school, and we'll label it with the variable C to match the variable on our diagram above. All right. Once we have our plots pointed, we can go ahead and draw some lines between them. And so I'll draw a line between my house and my friend's house. I'll draw a line that represents B to D, which is the time that we just waited on our friend before we left and walked to school. And then I'll draw a line from D to C, which represents walking from our friend's house to school. All right? And so once we have all that plotted and we have a graph, we can get a lot of information from this motion graph. And so the first thing that I am going to look at is our displacement after we've walked for 1 hour. And so I'm going to go ahead and label that as point E. And so I'm going to say over here, I'm going to give myself another point. E is equal to the displacement after 1 hour. And so if I look after 1 hour, 60 minutes on our chart, I can go up and I can see that we've traveled about 4 miles. And so in that time, 1 hour, we've traveled 4 miles. And let's label that on our graph as point E. And so why that's important is because we could know that if you'd been gone about an hour and an emergency happened and maybe your mom was trying to find you, she would know that you were about 4 miles away from your house at that time. And so again, we can get a lot of really useful information from this graph. Another thing that we can do is we can calculate the speed at which you are walking at. And so I'm going to go down here and I'm going to label this as what is our speed, how fast were we walking from our house or point A to our friend's house, which was point B. All right? And so to do that, we can look at this line. And this line has what's called a slope. And so that is basically the information for that line. And so in our case, speed is equal to the slope of that line. Okay. Now slope of a line is equal to its rise over its run. And so that rise is the amount of displacement in our chart, and the run is the amount of time. And so if we're figuring how fast we are walking from A to B, anywhere along this line we could pick a point and we could take the rise divided by the run and we'd get the same answer, and we would know how fast we were walking. And so I'm going to go ahead and I'm going to label this plot right here on our graph, and that's going to be the point that we use to calculate our rise and our run, so we can calculate speed. And so to get our rise at that point, it is 1 mile. Our run at that point, or our time in displacement, is between 10 and 20. It looks like it's in the middle, so I'm going to say it's at 15 minutes. So to get how fast we were walking, all we have to do is take 1 divided by 15, and it looks like I get, let's go ahead and round that to 0.07, and our unit here is miles a minute. Now we don't usually measure speed in miles per minute. We measure it in miles per hour. So we can do a quick conversion here to get miles per minute into miles per hour. So I'm going to take our number that we had, 0.07 miles a minute, and we're going to convert that into miles per hour. And so there are 60 minutes in 1 hour, and that should give us our answer. And so we'll take 0.07 times 60, and we get our number 4.2, minutes cancels out, and we're left with miles per hour. So I'm going to say miles per hour as mph. Then I'll go ahead and circle my answer. And so the speed we were walking at from point A to point B was 4.2 miles per hour. And I'm going to go ahead and I can go ahead and label that as point F on my graph. And over here I'll say F is equal to 4.2 miles per hour. So at point F, we're walking at 4.2 miles per hour. The next thing we're going to do is let's go ahead and calculate the speed. Okay. So we'll calculate the speed from B to D. So in this case, all of our information is going to be the same. Speed is equal to slope. Slope is rise over run. And so we can pick any point in our line here to get the speed. And so our line from B to D. And so our rise from B to D, from point B to D, is the top part. The run is the denominator. So how much did we rise from B to D? We rose 0 miles, so we didn't travel anywhere when we were waiting on our friend at his house. And the time that took was 10 minutes. And so, if I get my calculator out and I take 0 divided by 10, we're traveling at 0 miles a minute. So that makes sense because we have no slope in this line at all. 0 miles a minute is equal to 0 miles per hour. Okay. Now we'll calculate the speed from point D to point C. And so again, speed is equal to our rise divided by our run. We can go ahead and use from D here, we can use that point. And so our speed, we can use point E since we already have it marked. Point E is how many miles from point D. It's 2 miles. And our time it took to get from D to E is 20 minutes. And so there's 20 minutes from D to E, 10, 20. And so divide those two numbers, 2 divided by 20, and I get 0.1 miles a minute. I want to convert that 0.1 miles a minute into miles per hour, so it's a number I'm more familiar with. So we'll do our conversion. 60 minutes in 1 hour. 0.1 times 60 equals 6. Our minutes cancel out, and we're left with miles per hour. And so we traveled faster from our friend's house to school, and that's it. The interesting thing about that is we can tell because the line has a higher slope. And so I'm going to go ahead and label point E up here. We were walking at 6 miles per hour. All right, and